Welcome back to this next section. I'll cover a few more examples, example 4 and 5 in section 7.1 of your notes. This time I will go slightly in detail for the questions because it can be a little bit tougher. Let's take a look at example 4. Given this result, find the sum of the series. Let me change my ink color. Now, the first thing I want to do is to express this one, all right, in sigma notation. Because the result I'm given here is in sigma notation, right? I will try my best to express the given sum of this in sigma notation. Let's try and do this. I'm going to use, it is actually quite hard for us to write the general expression just by observing the terms like that. But you can get a very, very good clue, right, of the general expression by looking at the last term, correct? By looking at the last term. So if I write r 1 plus 3r here, it wouldn't go very wrong, honestly. Let's try. Right? If you start off with r equals to 1, start r1, then you will get 1 times 4, which is correct. Start r equals to 2, you get 2 times 7, which is correct. I think we're on the right track. Therefore, this is r equals to 1. The last term, of course, stolen from this last term here, will actually just be n. So we start there like that. All right? We start it like that. Let us then multiply it out. Good practice to put the brackets there, because if you don't put the brackets there, you don't know whether the summation is applied to the r or the 3r square or just one only. Now, I'm going to skip a few steps already because here, this first expression, we can actually split it up. We can do this now. Now, from here, you can actually apply this result. It's exactly the same. Just reminder, please check that the lower limit here, r equals 1 and r equals 1 are the same, right? You will get the same thing. Is that. Now, this is a simple AP. Yes, this is a simple AP, 1 plus 2 plus 3 all the way to n. So I'm going to put dot dot dot. You go and read on your own or do on DIY. Okay, read or DIY, you will get a final answer, which is n plus 1 square. Okay, I'm going to just leave it on your own now because this one is just this guy. This is a simple AP. You should be able to do it. I want to focus a little bit more on example 5. I want to use a bit more time on example 5. You still have the same result. Summation r square is this. Find this in simplified form. You realize that this expression looks a little bit more complicated. Let us try. First thing I will do, I will expand it out. Yep, I will expand it out. 9r squared minus 6r nr plus n squared. At this point, let us be very clear. Maybe I use a different ink here. R is the variable in this case. That means your first term is when you sub r equals to 1 into this expression. You will notice if you sub r equals to 1 into this n squared, the n squared doesn't change. It will always remain n squared. In this case, therefore, n is a constant. The r here is the variable. R equals 1, r equals 2, r equals 3. Correct? Let's be very clear. So I want to write it out like that. Correct? In this case, n is the constant. Right? R is the variable. So I'm going to split it up the summation now. 9r squared minus, because n is the variable, I can factorize 6n out of the summation. And I can factorize the n square out of the summation 1. This is the killer move actually, right? This is the killer move because n in this case is the constant, n squared is also the constant where r is the variable, right? From this point onwards here, if you see this one, it is almost the same as this. I say almost because this is n, this is 2n. Now if I change this, can I change this to k? This one will just be k, k, k. I can change this to m, it will just be m, m, m. I change this to 2n, also can. Correct? So all the n here will change to 2n. So I will write this down. It is 9, 2n, 2n plus 1, 4n plus 1, divided by 6. What about this term here? This term is again a simple arithmetic progression. 1 plus 2 plus 3 all the way to 2n. So I don't think I want to say so much. This is your n over 2, number of terms divided by 2 times first term plus last term, 1 plus 2n. And this one is even easier. This is basically just 1 plus 1 plus 1, 2n times. Therefore, this is n squared 2n times. So from this point onwards, it's all algebraic manipulation. Okay? Just combine, combine, combine. I leave it to read on your own because it's all printed in the notes. Eventually, we will get this. N 14 n squared plus 12n plus 3. This is the most important step already. From here onwards, it's all algebraic manipulation to get to this last point. Let's take a look at part 2 here. Hence find that. Okay, hence find something like that. Notice what we have gotten. We got this was 2n, right? This was 2n. You have found 2n is right. Is that? So how do you find all the way until 6n? It's not difficult. Part 2, correct? Sorry, I beg your pardon. I wrote it wrongly. I'm going to rewrite this slightly. Instead of 6n, I rewrite it as 2 times 3n and then 3n. Yes, because from part 1, maybe I write, part 1's result was this. Right? Part 1's result was this. Equals to some, oops, sorry, some long looking thing. Correct? 14n squared plus 12n plus 3. Now, whether this n can be n, it can be k, you can replace it by k, it doesn't really matter. Correct? This n, as long as you change all the n to something else, it's just a variable. So this time I rewrite this as 2 times 3n, and you notice now I can easily change this n to 3n. All are changed. Right? So therefore, I would replace, I highlight now, maybe I highlight like that. Look, this is 2, this is n, 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 n. I change all the n to 3n, 3n. So to get this, I don't think it's difficult. You will get a, replace this n with 3n, yes, then you get a 14, 3n squared plus a 12, 3n plus 3. In the end, you will get a final answer, which is your 9n 42 n squared plus 12n plus 1. Let's take a look at part 3 now. Use your answer in part 2 to find this. Now, I want to emphasize whenever they ask you to use your answer to in part 2 or use your answer from anywhere, you really must use the answer. You don't use the method. I repeat, you must use the answer. That means you must somehow make use of this guy. Yes, you must somehow make use of this guy. Now, it's pretty related. The way I will do it is this. Let's start off with what we want. Correct? This is what we want. How is it related to this guy? Actually, it's very much related. I can easily write this. Is it the same? If I factorize, if I square this inside, I will get a 9 and I put 1 over 9 like that. You multiply this out, you will surely get this. Agree? Why do I want to have a 3r minus 3n? Because I want to make this appear. So, actually, this is just 1 over 9 of your answer in. This is your answer in part 2. Correct? You can factorize the 1 over 9. That's not a problem. Answer is just very simple. 1 over 9 of this, which is, without the 9 here, final answer is just n 42 n squared plus 12n plus 1. I hope that helps for example 4 and 5. We'll do a short quiz and then we will carry on.